to another bonus episode of the Food for Thought podcast. I'm your host, Erin Hallstrom. Do you know what a SOYLEIC soybean is? Here to explain what SOYLEIC soybeans are and how they're being used to create a healthier food system is Bryan Stobaugh, Director of Licensing and Commercialization at Missouri Soybeans. During this episode, we talk about how SOYLEIC soybeans were discovered and what makes them non-GMO. We talk about the process of commercialization for SOYLEIC soybeans as well as where they can be planted. Enjoy the episode. Bryan, welcome to this special bonus episode of the Food for Thought podcast. Let's jump right into it. Can you explain to me what SOYLEIC soybeans are?
Sure thing, Erin. Thanks for having us on. SOYLEIC soybeans are a non-GMO, high-oleic, low-linolenic soybean that can be crushed, and using that oil that after it's crushed from the soybean as a whole seed, that oil can be used to place into many pieces of our food chain, as well as in our animal food chain. So what is SOYLEIC? It is a non-GMO, high-oleic soybean that was discovered here in Missouri.
Try saying that 3 times really, really fast. Definitely a complex name, but we like that. Tell me more about how they were discovered, and can you explain what makes them non-GMO?
For sure, and I've been working with this trait now for it'll be 6 years coming in January. So learning it and knowing it from the get-go has been a big part of it. So it's a lot of info to throw at someone at once. But let me tell you a little bit about its history. Genetics in soybean and genetic in crops, it all align. And what is really cool about the organizations that do this breeding is that they're teaching the future breeders of the world. And these breeders are trained to do many things from all kinds of crops, citrus. We were trained in all. I'm a soybean breeder as well. So what's the fun part? How was it discovered? This was discovered by a professor in southeast Missouri at one of our research locations, looking at the product and seeing that there were 2 parents that he can combine in a breeding aspect. And when he did that, he discovered that something changed in the amino acid profile. What is amino acid? That's what makes up the oil or the fat that's inside that soybean. And when he took that and discovered that new change or that altered resemblance of what was already in the bean, the oleic content went up. So what makes it non-GM? It is when it takes 2 plants and you take the flower from one and you cross it to the other. That is what makes it non-GMO. You have done no change to the plant itself besides making sure that 2 different versions of the soybean are combining together to make an offspring or make a new seed. So how do you make it non-GM? You take it and you make the crosses right there in the field, and that's how we train our future breeders.
All right. Can you walk me through the process of commercialization?
Sure thing. Commercialization, that's always the big question. This week I was at meetings and heard, we need more supply, we need more demand. Yes, we have to have both. Supply and demand are that action that drive a new product into the commercial space. The approach we took was a parallel approach of commercialization, where we are increasing supply and increasing demand based upon the number of product licenses we have out there. And we're fulfilling that goal year over year and increasing acreage year over year, Erin. Overall, we're seeing this product grow, and we're seeing groups come into this and take on licenses to commercialize. And each year, it's year over year increase in acreage. It's year over year increase in varieties. And look what we have. We have about 74,600 acres in the ground for commercial use this year, which is an increase of from last year in 2021's planting season of about 36,000. So we saw about a 2-fold increase. So it's a big win for us this year in 22.
Wow, that's definitely a lot of acreage. So I'm wondering, where can these beans be planted?
This is the great question. The part that makes SOYLEIC unique is that it was discovered through the university breeding program at Missouri. which sometimes we shorten to Mizzou. And that breeder was there in southeast Missouri, like I explained earlier. He and others saw this as an approach through work at USDA in the genetics side and mapping the genetics, and then work from United Soybean Board to put this in as many maturity groups. Maturity groups, that is what aligns soybean. The earlier the number, so let's say a maturity group 1 soybean, it's going to mature faster. That's Minnesota. If you come down to a maturity group 2, you're in the upper Midwest, and you come down to maturity group 3, it's right here hitting in the heart of Missouri. All the way from east to west, those lines line up. That goes to a 4, to a 5, 6, 7 maturity group is University of Georgia breeding program, and they do group 6s and 7. Right now, commercially, we have group 1, all the way down to a group 7, right out there with our licensees working on the commercialization of this, putting acres in the ground each year, and we're allowing this to be. We're seeing this grow. We're seeing this move of putting more ability of high oleic acres in more maturity groups across the country. So we're putting it on more soybean farmers' land across this great nation.
Talk to me about what leads to further use of the end product from SOYLEIC soybeans.
Sure thing. So the big benefits of the high oleic soybean, or what we commercialize the trademark for the commercial name is SOYLEIC health, the low saturated fats, and and it gives you the benefits of over conventional vegetable oils is the best way to describe that, contributing to lower blood pressure and cardiovascular health. It has a great sustainable approach. It has extended fry life, lower cost, waste, and less packaging required because it can extend the fry life used in the fryers across the country. The other thing is that it has a renewable source because soybeans make their own nitrogen. Soybeans also can be grown across the great nation. So therefore, they are able to make some of their own energy and move forward. The other thing is that fry life gives us 2 to 3 more times of overall use. There's a shelf life increase. And guess what? It gives you less absorption, leading to a cleaner, lighter flavor in your fried goods.
That's great. So can you describe what is being done to identify the crops grown in the U.S.?
So the best way to describe the growing process of identity preservation, and I may just say that as IP, that's identity preservation, gives you that ability to trace that crop from the day it was bred, the day it was grown and increased in acres, the day it was placed into a bag and then placed on a farmer's field, grown that year, sold at the end of the year, taken back and crushed, giving you that high oleic oil and that non-GMO soybean meal after the crush. So what is being done? Overall, our licensees are working independently within their own system of farmers and with their own group of farmers, and they are creating these identity preservation systems that grow the seed that they are getting from our breeding programs. And the breeding programs can be public breeding programs, so the universities, or they can be private, and we have private company breeding programs as well. And they are getting these lines, these varieties of high oleic soybean, and they're placing them on the farmer field and contracting that purchase back. Each one of those bags has SOYLEIC on there somewhere with the patent numbers associated. So that's how you identify the crop. That's how you get the crop in the ground. That's how the farmer gets to reap the benefit of growing a specialty crop on his farm, which equates to the ability for that farmer to gain further value from that grown acre, with it being a non-GM and high oleic soybean, which is a perk for the farmer overall. As we see, the world around us change, the high oleic soybean oil is giving them that ability to diversify on their crop acres.
Can you explain to me why the process took longer to bring SOYLEIC soybeans to the market as compared to others growing high oleic soybeans?
Sure thing. When we look at the others that are growing high oleic soybeans, they were using technology to make those genes be discovered through biotechnology, through gene edits. They were able to know exactly where and when that allele change happened to cause high oleic soybean to be expressed in the oil. So our high oleic oils to be expressed, so changing that amino acid. They knew on the DNA in the DNA helix, and when you look at the helix that we've all seen that looks like the twisted ladder, they've taken that and they knew exactly where it was. When we go back to my earlier question you asked me, Aaron, about how we look at traditional breeding and we're making that cross in the field, when we're making that cross, we don't know how all of the genetics are going to align. And when we're making that first instance of how did that combination happen to change high oleic, the biotechs knew it was going to happen because they had a region in the DNA that they knew was going to change the amino acid. What happened with traditional breeding and the creation of SOYLEIC soybeans, it was the ability to cross and then take that probability of what chance those two parents that made that new seed had the ability to express an increase in oleic content. Then it took several crosses, so that's years of growth, year over year, one cross, one growing season is the only time you can get that one cross established. And you're crossing back to that parent that you think is giving you that new expression of high oleic. So instead of being able to pinpoint and know exactly what's happening through our processes of science, which we are grateful for, and we're grateful for our friends that work in this project area of high oleic with biotech and with gene edits, the SOYLEIC approach was let's go back to the basics of traditional soybean breeding, creating a non-GMO version, and it just takes a little bit longer. Then you have to find the spot that this aligns in the DNA sequence. Then you have to then breed that back into your high-yielding, disease-resistant, great varieties that are across many maturity groups. It just took a little bit longer. The overall process is the way we had to do it to keep the product as a non-GM. The faster way is by using science and using biotechnology and gene edits. And we, like again, I said, we are ecstatic for them and for their work and their ways of paving the acreage increases year over year we've seen. But, the ability to give the consumer and the buyers that opportunity to have a non-GM SOYLEIC fit that portfolio. And that's how it was created, through non-traditional, conventional soybean breeding right here by students and researchers alike in Missouri.
Well, Bryan, you definitely provided a lot of great information to consider. So thank you again for joining me today on this special bonus episode of the Food for Thought podcast.
For everyone listening to the Food for Thought podcast today, thank you for tuning in. You can find us on Apple Podcasts, Spotify, Stitcher, and just about everywhere you can listen to a podcast. Be sure to tune in next time as we talk more about the stories behind the headlines of the food and beverage industry. Take care. Have a great day.